How's it going, Mathaholics? I'm glad to see you all stop by to watch a math video today. Today we're going to be talking about rational and irrational numbers, but before we do that, I just want to mention once we get to 150 subscribers, we're going to give away 3 free Cane's gift cards. So if you like chicken as much as I do and want to have a chance to win some of those gift cards, just hit that subscribe button below and hopefully you get selected. So without any further ado, let's start talking about these rational numbers. Now, sometimes when we don't know what to do, whether it be in one of our classes or even in math or in life, we like to look at little hints to kind of guide us in the right direction. And fortunately, with rational numbers, the hint is in the word itself. We see the word ratio in rational numbers. So what does that really tell us? That basically means that a rational number is any number that can be represented with a ratio. I'm going to go ahead and write that in case you want to write it down too. Number that can be represented. And that does look a little small, so I'm going to try to make it more legible. However, I don't know why it's not zooming in. Here we go. A rational number is any number that can be represented as a ratio. Okay. For whatever reason, the font wasn't getting larger when I was telling it to, so I just had to zoom it in. But I hope you picked up on that definition. So what do I mean by a number that can be represented as a ratio? Let's start with the numbers that we learned in kindergarten. 1, 2, 3, 4, 5, and so on. How can I represent each of these numbers as a ratio? Well, let's start with the number 1. 1 is just the same thing as 1 over 1, or 100 over 100. 1 million over 1 million. You get the point. All of these cancel out to give us 1. Now let's look at the number 2. 2 is also a rational number because we can write it as 2 over 1, 4 over 2, 8 over 4, and so on. Now, what else can we do with these rational numbers? You get the point. We can write 3 the same way, 3 over 1, 6 over 2, things like that. So let's look at a different example. Now these examples, sometimes they're given to us just to throw us off, but if we look at them today, when the test comes around, we'll be a master of them, so they're not going to be able to confuse us anymore. Square root of 4. Is this a rational number? Yes or no? Well, I don't know what you said, but I'm going to just tell you what the answer is. The answer is yes, and that's because square root of 4 is the same thing as 2. And 2, as we saw from our example earlier, 2 can be written as 2 over 1, 4 over 2, and so on. So that is another way we can look at rational numbers. Always think about if you can simplify them, and if you can simplify them, can they be written as a ratio somehow? And if the answer is yes, then you know that they are a rational number. Let's look at a few more rational numbers, just so that we understand it and completely master it. 2.75. Is this a rational number? Yes, even though it's a decimal, we can write 2.75 over 1, or we can write 2.75 as 275 over 100, and that'll give us 2.75. So once again, this is a ratio just like any other ratio, and that is why 2.75 is a rational number, even though it has a decimal, or even if it had a negative in front of it, then we would just have to write this as a negative number. That's all it is. So don't let all these little extra steps confuse you. Just remember, as long as it can be written as a ratio one way or another, the answer is yes, this is a rational number. Now let's look at a few more that might be a bit confusing at first, but they're really easy once we understand them. 0.3 repeating. How do I write a number that goes on forever as a rational number? It seems pretty much impossible, because if I wanted to write this as 0.3333333, before I could put it over 1, I would have to keep writing these 3's forever, because if I stopped right here, let's say, this would still be technically incorrect, because the 0.3 repeating goes on forever. And as you can see here, I maybe wrote like 15 3's. It doesn't even look like 15, but approximately 15 3's. And we know there's a lot more than 15 in forever. So how can I write a repeating number forever? Well, in this case, we know that, let me just delete this to make some more room for you all. There we go. We know that 0.3 is the same as 1 over 3. And if I leave this as a fraction, that is the same thing as if I had a 0.3 repeating on forever. So, as I mentioned, this is just another one of those trick questions, if you want to call it, but always try to think outside the box when it comes to these rational and irrational numbers, because the test proctors or the test or whoever, the homework, it could be trying to trick you. But if you think outside the box and just try to figure it out that way, ask yourself if there's any way possible that it could be written as a ratio. If you can find at least one correct way, I guarantee you that it is a rational number. Now that we've covered a lot of the rational number examples, you might be wondering, I can't think of any number that would be irrational. I already told you if the number is negative and a decimal, like negative 2.75, we can still write that as a ratio. Negative 1 million can be written as a ratio. So what number is there even in the universe that is an irrational number? Well, that is why I'm here today. I'm here today to show you what these numbers are. So let's move on to irrational numbers. And as you could probably guess, an irrational number is a number that cannot be written as a decimal. So what kind of numbers are these? Let's start with a few of the famous examples. Pi. We learned pi to be 3.14. However, there's a little more to pi than what meets the eye, and that kind of rhymed. It wasn't intentional, but we're just going to go with it. 3.14, as I'm sure most of you know, it goes on forever. So it's 159, and I don't remember the rest off the top of my head. I think the next number is a 2, but basically, pi goes on forever. So unlike the 0.3 repeating that we could just write as 1 over 3, there's really nothing that I could write pi as a ratio that would give me an accurate number. So pi is going to be an irrational number. Now, what other numbers are irrational? E, for example. E is equal to 2.71828, but it also keeps going on forever. Now, let's look at some other ways of looking at irrational numbers. Earlier, I mentioned square root of 4, and I asked you, is this number going to be rational or irrational? And we came to the conclusion that it is a rational number because square root of 4 is the same as 2, and as I mentioned twice already, 2 can be written multiple ways. Knowing that square root of 4 is a rational number, is the square root of 2 also a rational number? Unfortunately, it is not, because if we put square root of 2 into our calculator, we will get something like 1.414, and this number will just continue to go on forever. And that is why square root of 2 is not a rational number. Also, square root of 3, it does not give us any clean number. I think it's like 1.7, something like that, and then it just keeps on going on forever. That being said, I have a couple questions. Let's see if we understand it all. Is square root of 9 a rational number? Yes or no? Well, the answer would be yes, because that is just 3, and we can write 3 as a ratio. Square root of 2, well, I already told you guys it's no. Or let's not write no, let's write irrational. In case anybody is not watching the video and just skipping through to get the notes, I still want you to learn something. And you get the point from here on out. So like I said at the start of the video, always ask yourself, can I write this number as a ratio one way or another? And if the answer is yes, just know that it is a rational number. If it's no, then it's an irrational number. It is a bit of a simple concept. It takes some time at first to really get the hang of it, but I promise once you get done with this, you won't really need it for much later on in the future. If you have any questions, please comment them down below or send me an email and I'll be happy to answer them. Thank you, and I hope you learned something from this video.